My lovely students, welcome to Mathological. In this session, we'll be discussing what are relations, how are relations connected to sets, and why are relations a prerequisite to functions, to understanding functions better. Watch this session from start to end in one go, and you will be understanding the whole topic of relations very smoothly. Okay, start karte hain. And if you've not already subscribed to the YouTube channel and you like the content, then make sure to subscribe to the channel as well as press the bell icon. You can also message me on Telegram at ADITYAKT. My name is Aditya Tiwari, and now we are starting the topic relations. So, what are relations basically? Let us start with some basics, some basic examples. Very basic examples. Okay? By defining some very basic relations. Let us say we are saying that friends is a relation, isn't it so? And if friends is a relation, let us say A and B are friends. Okay. So if A and B are friends, then in that case, B is a friend of A. B is a friend of A. Similarly, A is also a friend of B. Okay. Second relation example could be that let us say we are saying that X is less than Y. So one example of this, we can say that 5 is less than 7. Now 5 is less than 7, but definitely 7 is not less than 5. Isn't it? So in the first case, when A and B were friends, because friends was also a relation, so A is a friend of B, B is a friend of A. So if we write an ordered pair, so A comma B, where we say that B is a friend of A, that is also fine. And if we write B comma A, where we say that A is a friend of A, that is also fine. Both are fine. But in the second scenario, 5 is less than 7, that is correct. Okay, 5 is less than 7, this relation is correct. But 7 is not less than 5. Isn't it so? Because of the ordered pair. Okay, so 7 is not less than 5. So in first case, both were true, A comma B, B comma A. Second case, 5 comma 7 is defining, satisfying the relation, but 7 comma 5 is not satisfying our given relation. Isn't it so? क्या ये बात clear है? So basically, in case of a relation, in a relation, elements, which in first case are A and B, second case are 5 and 7, elements are related by a statement. And that statement is defining the relation. So that statement defines the relation. This defines the relation. Is that clear? We've understood it non-mathematically for now. Now let's make it more formal. Make the definition slightly more formal. So if we are talking about relation between sets, because even in this case, भाई friends भी क्या है, sets ही होगा, ठीक है? तो set तो किसी भी चीज का बना सकते हैं. So what is relation between sets? Relation between sets. So how elements from one set correspond to elements in the other set, and that is represented as ordered pairs. So relation between sets is how elements from one set correspond to elements from other set. And this is written as ordered pairs, because order is also important when we are defining a relationship, as we understood in the first case that A comma B are related as friends, B comma A are also related as friends, but in the second scenario 5 comma 7 are related as X less than Y, but 7 comma 5 are not related in the same manner. That is why order is also important. Order plays an important role, and that is the reason we write this is in an ordered manner, in ordered pairs. Ordered play an important role. That is why ordered pairs are important. क्या ये बात अप्रिशिएट कर पा रहे हो, समझ पा रहे हो? ठीक है, मैंने कोशिश किया है तुमको नॉन फॉर्मली बेसिकली चीजों को फंडामेंटली समझाने कि why ordered pairs are important in case of a relation. Is that clear? Now, why is this important for a function? Because relations, basically, they also help in defining functions. And why is that so? Because function is a specific type of relation. A specific type of relation. So first we'll be understanding relations in general, and then we'll be going in particular with functions. So what is a function? What is so specific about it? Okay. But before that, let us understand the Cartesian product of sets. Because at start to set से ही होगा. So what is a Cartesian product of sets? So let us say we have two sets, two non-empty sets, two sets with definitely at least one element. If we have two non-empty sets, A and B, so in that case, the Cartesian product that is defined as A cross B is basically a set of all ordered pairs of elements from A to B. Set of all ordered pairs of elements from set A and B. बिना एग्जाम्पल के तो बात समझ में आएगी नहीं. So we'll be taking one example and then we'll be understanding it better. Okay. But let us define it first mathematically as well, that A cross B that represents A comma B such that A is element of set A, small a is element of set A, and small b is element of set B. Now small letters represent the elements and capital letters that represent the sets. Okay, so let us take one example to understand it more better. Let us say we have a set A, and that set A is having elements 1, 2 ka 4 and 4, 2 ka 1, basically 1, 2 and 4. And there is another set B that is having elements 3 and 5. And now we have to define A cross B, the Cartesian product of sets A and B, to A cross B. So let us write these sets, set A, 1, 2 and 4. Similarly, set B with two elements 3 and 5. Now we have to make all set of all ordered pairs of elements from A and B. Okay, so all ordered pairs from A to B. A cross B will be starting with A. The first element will be from A. The second element of the pair will be from B. So we can connect 1 with 3. So 1 comma 3 will be our first ordered pair. Similarly, we can connect 1 with 4, 5. So 1 comma 5 will be second pair. By the same logic, we can connect 2 with 3. So 2 comma 3 will be third pair. We can connect 2 with 5. So 2 comma 5 will be our fourth pair. Similarly, 4 comma 3 and 4 comma 5. So these are all the pairs possible in Cartesian product A cross B. Number of elements कितने आएंगे? Number of elements in A cross B. भाई A cross B is also a set as such. ठीक है ना? A set. So what are number of elements in A cross B? Number of elements are 6. And basically, set A has 3 elements. Cardinality of set A is 3. Set B has 2 elements. So number of elements in Cartesian product A cross B, this is equal to number of elements in set A multiplied by number of elements in set B. Isn't it so? Is that clear? So number of elements in Cartesian product A cross B, that is equal to number of elements in set A multiplied by number of elements in set B. Similarly, if we define B cross A, pause the video and define it yourself. What will be number of elements? What will be elements in B cross A? अब B cross A में क्या है? First element will be from B, second element will be from A. तो B से A पे जा रहे हैं, तो first element is from B, तो we can choose 3 and 3 comma 1, 3 comma 2, 3 comma 4. Similarly, we can have elements 5 comma 1, 5 comma 2, 5 comma 4. So can you understand that number of elements in B cross A is also equal to 6? So B cross A also has 6 elements by the same logic, but B cross A is not the same as A cross B. So A cross B and B cross A, they are not equal. Number of elements equal हैं, but they are not equal. A cross B is different because in case of A cross B, the first element pertains from set A, second element pertains from set B, and in case of B cross A, the first element pertains from set B and second element in each ordered pair pertains from set A. क्या ये बात appreciate कर पा रहे हो? Is that much understood? Is that much understood? ठीक है? So if that much is understood, then let us solve our first question. Let us do our first question based on that. So the question is, if there are sets, set A 1, 2 and 3, set B with elements 3, 4 and 5, set C with elements A, C and D, set D with elements A, E, I, O, U, then find number of elements in the Cartesian product of A union B cross C union D. So this is our first set, A union B, set 1. This is our second set, C union D, set 2, and we have to find out Cartesian product of these two sets. Cartesian product of these two sets. So A union B क्या आ जाएगा? A union B will have elements 1, 2, 3, 4 and 5. Similarly, C union D, this will have elements A, C, E, I, O, U. ठीक है, E सेट C में भी है, D में भी है, तो एक ही बार काउंट होगा, तो A, C, E, I, O, U. Now order of the elements in a given set, that is not important, number of elements is important. ठीक है, तो A, C, E की जगह A, E, C लिखोगे तो भी चलेगा. So that order is not of much relevance. Number of elements in A union B कितना है? This is equal to 5. And number of elements in C union D, this is equal to 6. हमें चाहिए number of elements in the Cartesian product A union B cross C union D. So that will be equal to number of elements in A union B multiplied by number of elements in C union D. And the answer for this question, this will be 5 into 6, which is equal to 30. So there will be total 30 elements in Cartesian product of A union B cross C union D. Appreciate कर पा रहे हो? Is that much clear? ठीक है. So our answer will be 30 in this case. Okay. अब कार्टेशियन प्रोडक्ट पूरा निकालने की जरूरत तो नहीं है, सिर्फ और सिर्फ नंबर ऑफ एलिमेंट्स ही चाहिए था. सो आंसर विल बी 30 इन दिस पर्टिकुलर केस. ओके, ठीक है, वेल एंड गुड. नाउ दैट वी आर डन विद कार्टेशियन प्रोडक्ट, coming back to relations. A relation. So now that we've understood the Cartesian product, basically a relation R is defined from a non-empty set A to non-empty set B such that the relation is a subset of the Cartesian product A cross B. A relation R from a non-empty set A to another non-empty set B is basically a subset of, this is a subset of Cartesian product A cross B. So if R is a relation from A to B, in such a case, R is a subset of A cross B. If R is a relation from A to B, in that case, this implies that R is a subset of relation that we are defining with R, that is a subset of A cross B. Now that can be a proper subset, ठीक है, or improper subset. Improper subset यानी कि implies R contains all elements of A cross B. That is also possible, or some of the elements. So R can contain some or all elements of A cross B. Some / all elements of A cross B. Okay, clear? And this is written mathematically as that R is a relation from A to B. That is why arrow is from A towards B. ठीक है, A is our first set and B is our second set from A to B. and set of all first elements in the ordered pair. Set of all first elements in the ordered pair they are called domain. And similarly, set of all second elements in the ordered pair they are called range. And the whole set B, this is our codomain. डोमेन, रेंज, कोडोमेन, सम टेक्निकल टर्म जिनको कि अभी हम एग्जांपल से और बेटर तरीके से समझेंगे. एंड इन ऑल केसेस दिस रेंज विल ऑलवेज बी अ सबसेट ऑफ कोडोमेन. Range will be a subset of codomain. Is that much clear? क्या ये बात क्लियर है? क्या यहां तक समझ पा रहे हो? Okay. So some more technicality. So if we are saying that A comma B, an ordered pair is there of A comma B, and that is the element of our relation R. So this can also be written as A R B. यानी कि A is related to B. Order is also important. ठीक है? So A R B. Or the same thing can be written as A is related to B. A is related to B. By the same fashion, if we are saying that A comma B is not an element of R, then this implies that A, R को cross कर दोगे, A is not related to B. Similarly, this is written in English as A is not related to B. Very obvious. Okay. Clear है? ठीक है. So next part, total number of relations possible. Total number of relations possible. So if we are taking Cartesian product A cross B, number of elements in A cross B कितना होगा? If number of elements in A, set A, that is equal to, मान लेते हैं set A में number of elements हैं अपने n1 मान लेते हैं n1, and set number of elements in set B, let us say that is equal to n2. Let us say that is n2. तो अगर number of elements in A is equal to n1, number of elements in B is n2, तो number of elements in set A cross B कितना होगा? That will be equal to n1 into n2. n1 into n2. Okay, n1 into n2 elements हैं in Cartesian product of A and B, A cross B. ठीक है, तो how many relations are possible? अब now in a relation since a relation जो अभी definition में देखा, relation R from a non-empty set A to another non-empty set B, that is always a subset of A cross B. और अगर सबसेट है A cross B का, तो A cross B में number of elements कितने हैं? n1 into n2. So for each element we have a choice. Either that element will be part of the relationship or will not be a part of relationship. या तो that will be a part of relation or will not be a part of relation. So for every element there are two choices. Number of elements is n1 into n2. So for every element there are two choices. So total number of relations will be in such a case. Take a total number of relations from A cross B, from A to B possible. That will be 2 to the power n1 into n2. Or which is 2 to the power number of elements in A multiplied by number of elements in B. क्या ये बात अप्रिशिएट कर पा रहे हो? क्लियर है? ठीक है, एग्जाम्पल से समझेंगे तो और बेटर समझ में आएगा. बट क्या ये बात समझ पा रहे हो? ओके, सो अनदर क्वेश्चन विद दैट. एक और क्वेश्चन लेते हैं. तो इफ अ सेट P हैज 5 एलिमेंट्स एंड सेट Q हैज 6 एलिमेंट्स, then find a number of relations defined from P to Q. What will be number of relations from P to Q? Options हैं हमारे पास 8 to the power 8, 8 to the power 10, 10 to the power 8, and 16 to the power 8. So what should be the answer? Set P has 5 elements, set Q has 6 elements. तो number of relations defined from P to Q क्या होगा? So P cross Q, which is the Cartesian product of P and Q, will be having number of elements that is 5 into 6, 30 elements. And any relation any relation will be a subset of P cross Q. Will be a subset of P cross Q. So any relation can have maximum 30 elements, और हर एक एलिमेंट के there will be two choices. So total possible number of relations will be equal to 2 to the power number of elements in P cross Q, 2 to the power 30. Our answer will be 2 to the power 30, but वो तो given नहीं है, या तो 8 की पावर में आ रहा है, या 10 की पावर में, या 16 की पावर में. Definitely since 2 to the power 30 is the answer, तो ऑप्शन सी तो आंसर नहीं होगा. अब या तो 8 की पावर में कन्वर्ट करें या 16 की पावर में, तो 2 to the power 30 कैन बी रिटन एज 2 to the power 3 to the whole power 10. ठीक है, so that is equal to 8 to the power 10. So our answer will be option B. 8 to the power 10 will be our answer in this case. Clear? Okay, is that much clear? ठीक है. Now sometimes in some cases we can have a relation from a set A to the same set. ठीक है, from set A to set A. Now this is known as relation on A. Relation on A. Where the two sets from set A to set A, both sets are same. In that case, that is said as relation on A. Okay. अब एक एग्जाम्पल लेते हैं अपने रिलेशन का, एक प्रॉपर एग्जाम्पल लेते हैं, सो दैट वी कैन डिफाइन रिलेशन मच बेटर वे, इन मच बेटर मैनर. डेफिनेशन तो समझ ही गए, बट नाउ वी हैव टू अंडरस्टैंड द एप्लीकेशन ऑफ this definition, application of the concept of relation. Let us understand that as well. Let us say we have two sets, set A, and set A has elements 1, 2, 3 and 5. And there is another set B, and set B has elements 4, 7, 10 and 13. And then we are defining a relation. अच्छा, A cross B में number of elements कितने होंगे? A has 4 elements, B has 4 elements, so A cross B will have 4 into 4, 16 elements. And let us define the relation. Our relation R is such that ordered pairs लेते हैं. So 1, 4 is one ordered pair in this, 2, 7 and 3, 10. These are the ordered pairs. These are 3 elements in our relation R. Or the same can also be written as that R, our relation R is equal to A comma B such that B is equal to 3A plus 1. A comma B such that B is equal to 3A plus 1, and A is element of set A and B is element of set B. Now this is another way to define the relation. ठीक है, अब क्या ही करें कर पा रहे हो, इफ B इज इक्वल टू 3A plus 1, तो अगर हमने पहला सेट से एलिमेंट लिया फ्रॉम सेट A हैज एलिमेंट्स 1, 2, 3 and 5, and set B has elements 4, 7, 10 and 13. So if B is equal to 3A plus 1, now if we take first element from set A, that is equal to 1, so B is equal to 3A plus 1 है, B is equal to 3A plus 1. So if A is equal to 1, then B becomes 3 into 1 plus 1, which is equal to 4. So 1 is related with 4. Isn't it so? 1 is related with 4. So 1, 4 will be first ordered pair. Similarly, if we take A is equal to 2, the second element of set A, if we take A is equal to 2, in that case B becomes equal to 7. So 2 is related to 7. That is our second ordered pair. Similarly, if we take third element of set A, that is equal to 3, so 3 into 3 plus 1, that is equal to 10. Or 10 is also there in set B. So 3 is related to 10, third ordered pair. Now fourth element of set A क्या है? 5 है. So if we take A is equal to 5, तो 3 into 5, 15 plus 1 becomes 16. But there is a problem. Problem क्या है? Problem ये है कि set A में 5 तो है, but set B में there is not corresponding element 16. 16 is not there. तो since 16 is not there, तो 5 को हम relate नहीं कर पाएंगे with set B. ठीक है, एलिमेंट ऑफ सेट ए दैट इज 5 कैन नॉट बी रिलेटेड विद एनी एलिमेंट ऑफ सेट बी, दैट इज वाई 5 को क्योंकि हम रिलेट नहीं कर पाएंगे, तो 5 का हमें इमेज नहीं मिल रहा है, 5 का हमें जो काउंटर पार्ट है that is 16 is not there in set B, so we cannot relate 5 with any element of set B. तो 5 के corresponding ordered pair हमें मिलेगा नहीं. That is why we have only 3 elements in this relation R. क्या ये बात क्लियर है? ठीक है. 5 के लिए there is no corresponding pair. एंड सिमिलरली सेट बी में there is 13 जिसके करस्पॉन्डिंग कोई पेयर हमें सेट ए में नहीं मिल रहा है. अगर सेट ए में 4 होता लेटेस्ट से, इफ देयर वाज 4 इन सेट ए, देन 4 into 3 plus 1 would have been 13. ठीक है, बट 4 is not there. So we have no pair for 5 in set A and no pair for 13 in set B. But rest things are there. ठीक है, rest things are there. Now what is the domain? Domain in this case, domain क्या होगा? ठीक है, what will be the domain? Now domain will be having those elements which are in set A and have a corresponding element, a related element in set B. So 1, 2 and 3, these 3 should be our domain. The first element, domain is basically all the first elements of the relation. Okay, so 1, 2 and 3, these are the set of domain. So domain of relation R, this will be 1, 2 and 3. Okay, similarly range of set R. Now range will be containing all the second elements, which is 4, 7 and 10. All the second elements 4, 7 and 10. Obviously 13 is not there because 13 is not part of the range, but 13 is part of the set B. Set B का तो part है, और set B को हम क्या कहेंगे? This is also codomain. So 13 is part of the codomain. So codomain of relation R, that will be set B only. This is equal to B. So set B contains 4, 7, 10 and 13. ये ध्यान रखना, ठीक है. बट रेंज इज नॉट इंक्लूडिंग 13 बिकॉज 13 के करस्पॉन्डिंग हमारे पास सेट ए में देयर इज नो एलिमेंट. तो डोमेन इज हैविंग एलिमेंट्स 1, 2 and 3, नॉट 5 because 5 के corresponding there is no element in set B. Range is having elements 4, 7 and 10, and codomain, which is B itself, that is 4, 7, 10 and 13. And obviously in this case, the codomain, the range of R, that is a subset of codomain. That is always there. This is always there. Range is always a subset of domain, codomain. Sometimes range is also equal to codomain. अगर 13 के करस्पॉन्डिंग एलिमेंट मिल जाता तो रेंज और कोडोमेन इक्वल हो जाता, बट ऐसा तो है नहीं इस केस में. तो इस केस में रेंज इज अ सबसेट ऑफ, इनफैक्ट अ प्रॉपर सबसेट, बिकॉज 13 के करस्पॉन्डिंग देयर इज नो एलिमेंट. तो दैट इज व्हाई देयर इज वन एलिमेंट जिसके करस्पॉन्डिंग हमारे पास जो एलिमेंट हमें रेंज में नहीं मिल रहा है. दैट इज व्हाई रेंज इज अ प्रॉपर सबसेट इन दिस केस. अदरवाइज रेंज इज ऑलवेज अ सबसेट ऑफ कोडोमेन. इज दैट क्लियर? ठीक है, दैट मस्ट शुड बी क्लियर. ओके, एक और एग्जांपल लेते हैं to understand this more better. एक और एग्जांपल लेते हैं. Let us say we have a set A that contains elements 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. And then we are defining the relationship between x and y. X is related to y such that y is equal to 2x plus 1 and x comma y are element of A. X is also element of A, y is also element of A. Now in such a case, since x और y को हम related कैसे कर रहे हैं, that y is equal to 2x plus 1. ठीक है, और अगर हम प्रॉपर वे में डिफाइन करते तो r was equal to x comma y such that x and y कैसे related है, that y is equal to 2x plus 1 and x is also element of A, y is also element of A. So if both x and y are element of A, तो basically क्या है, this is a relation on A, isn't it so? Relation on A, relation from set A to set A, isn't it so? क्या ये क्लियर? तो अभी रिलेशन प्रॉपर्ली हमको डिफाइन करना है. तो एक बार अपना इनपुट सेट क्या है, इनपुट सेट भी सेट ए है और आउटपुट सेट भी सेट ए है. तो एक बार प्रॉपर्ली सेट ए को इनपुट आउटपुट दोनों को लिख देते हैं. तो 1 से लेकर 12 तक की वैल्यूज को लिख देते हैं. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. दिस इज अवर इनपुट सेट. set A containing the domain and output set, that is also 1 2 3 4 5 6 7 8 9 10 11 12, which is our codomain. Okay, now y is equal to 2x plus 1. अब x की जगह पे we can put x equal to 1. If we put x is equal to 1, so in such a case, what will be the value of y? 1 into 2 plus 1, that is equal to 3. So corresponding element related with 1 is 3. Similarly, if we put x is equal to 2, so 2 into 2 plus 1, that is equal to 5. 2 is related with 5. 3, the corresponding element will be 7. 3 is related with 7. 4 is related with 9 in the similar fashion. And then 5 is related with 11. Now for x is equal to 6, y becomes 13. और फिर उससे बड़ी वैल्यू आएगा, but 13 is not there in set A. So this will not be a relation. So only 5 relations are possible. 5 elements are possible in this relation. When x is equal to 1, y is equal to 3, x is equal to 2, y is equal to 5, x is equal to 3, y is equal to 7, x is equal to 4, y is equal to 9, and x is equal to 5, y is equal to 11. Only 5 elements are possible in this relation. So we can write this relation as having elements, order is important, 1, 3, 2, 5, because x will be preceding the y. Okay? And then 3, 7, 4, 9, and 5, 11. These are all the elements. Okay, domain of our relation R, this will be having all the first elements. 5 elements are there, 1 2 3 4 and 5. This is our domain. And range of our relation R, this will be having all the second elements, that is 3 5 7 9 and 11. And codomain is obviously set A only. Codomain is set A only. And of course, our range is a range of R. This is a subset of codomain. Isn't it so? Clear? Okay. ठीक है. Now let us take some cases of relations to understand it much better. We have a set A and a set B. And set A has elements 1, 2 and 3. Set B has elements A, B and C. The first and simple case can be when 1 is related to A, 2 is related to B, and 3 is related to C. Our relationship is from A to B. 1 is related to A, 2 is related to B, 3 is related to C. Now, in such a case, exactly one element in all the cases, exactly one element of set A is related to one element of set B. So such a relationship is called 1-1 relationship. Because one element of from set A is related with one element of from set B. The 1-1 relationship. Okay. Second scenario could be when one element from set A, some of the elements from set A are related to more than one elements in set B. Properly represent करेंगे. So if we have A and B, let us say this is a relationship R2, relation R2 from A to B. A has elements 1, 2 and 3. B has elements A, B and C. Now in such a case, let us say that 1 is related with A as well as with B and 2 is related with C. Now in this case, exactly one element 1 is related with more than one element. So one to many relationship, this is known as, because one element is connected with many, even if that is exactly one, only one. Okay, rest of the elements are connected with one element, that is also fine. But if even one element is related with more than one elements, then that relationship is known as one many relationship. This is second type of relation. First type was when 1 was related to exactly one. Second type, when one element from input set from set A is related with more than one element in set B, even if that is only one element. Okay, for even if for rest of the elements they are connected with one only, but if there is just one element is there that is connected with more than one elements in set B, then that relationship is known as one many relationship. Third scenario could be, well, let us say one is related with A and 2 is also related with A. यानी कि many elements in our set A are related with the same element in set B, then this is known as many one relationship. Many one relationship. Let us say that this is relation R3 from set A to set B. And final scenario, let us say relation R4 from A to B. That will be a many relationship. A many relationship. That will be like, let us say one is related with A as well as B, यानी कि one element from set A is related with multiple elements in set B, and similarly multiple elements from set A also related with same element, one element of set B. So this is a many relationship. Many relation. So these are the four cases: one one many one, and many. अब इनके एग्जांपल्स भी देख एक नोट कर लेते हैं. फॉर एग्जांपल लेट अस से example of first set R1, that can be y is equal to x plus 1. So in such a case, if we take x is equal to 1, y will be 2, x is equal to 2, y is equal to 3, x is equal to 3, y is equal to 4, यानी कि this is a relationship. और यहाँ पे exactly one element from set A will be related to one element of set B. Isn't it so? So this is an example of R1, यानी कि one relationship. Second example, R2, one to many relationship, that can be x is equal to y square. X is equal to y square. For example, 1 comma 1 and 1 comma minus 1. So if y is equal to, if x is equal to 1, then y can be 1 as well as minus 1. ठीक, if x is equal to 1, input is equal to 1, so y can be plus 1 as well as minus 1. So 1 in our input can be connected with plus 1 as well as minus 1. That is our example of R2 relationship, यानी कि 1 to many relationship. Third example for R3, यानी कि many one relationship, that will be equal to y is equal to x square. Y is equal to x square. If x is plus 1, then y can be 1. If x is minus 1, then also y can be 1. ठीक है. So 1 comma 1 and minus 1 comma 1 relationship R3. और R4 का example can be that y square is equal to x square. Y square is equal to x square. यानी कि 1 comma 1 is also satisfying this. 1 comma minus 1 is also satisfying this. Minus 1 comma 1 is also satisfying, and minus 1 comma minus 1 is also satisfying this. That is many relationship. क्या ये बात अप्रिशिएट कर पा रहे हो? सारे एग्जाम्पल में समझ लिया? क्या है क्लियर? इज दैट मच क्लियर? ठीक है, इज दिस मच अंडरस्टूड? अच्छा, हाउ इन दिस केस देखो R1 हमारा दिस इज फाइन एज अ फंक्शन एज वेल. रिलेशन तो सारे के सारे हैं, बट R1 विल बी क्वालिफाइंग एज अ फंक्शन एज वेल, यानी कि 1 इज क्वालिफाइंग एज अ फंक्शन एज वेल. सिमिलरली R3 is also a fit case for a function. ठीक है, R3 will also be a function, यानी कि many one relationship, that is also a function, that can also be a function, this can be a function and this can be a function, but these two R2 and R4 these cannot be a function. बाकी डिटेल में फंक्शन वाले सेशन में समझेंगे, नेक्स्ट सेशन में समझेंगे, बट क्या ये बात अप्रिशिएट कर पा रहे हो कि वी हैव 4 केसेस बेसिकली ऑफ रिलेशनशिप, वन मेनी वन एंड मेनी. ओके, 4 cases are possible in this case. Clear? Now last concept, that is inverse of a relation. Inverse of a relation. Now if we have a set R that is defined as a comma b, ठीक है, such that कुछ भी रिलेशनशिप है हमारा ए आर वाई लिख देते हैं, ए आर बी, where A is an element of set A and B is an element of set B. In such a case, R inverse or inverse of the relation that is equal to B comma A, where A and B are related. A is element of set A and B is element of set B. So R inverse is just having the ordered pair jumbled. Ordered pair में order change हो जाता है हमारा, nothing else changes. ठीक है. So in such a case, domain of range R inverse will be a range of R, and range of our relation R inverse that is equal to domain of range R. Okay, is that much clear? ठीक है, इसके लिए एक एग्जांपल ले लेंगे तो बेटर समझ में आ जाएगा. एक सिंपल सा एग्जांपल लेते हैं. Let us say we have a set S and S is having elements 1, 3, 4 and 6. Let us define a relation between the elements. So we are defining a relation R such that R has ordered pairs A comma B and A comma B are connected in a manner that A is less than B and both A and B are elements of S. And this is a relation on S because input set is also S, output set is also S. S को input और output दोनों sets में लिख देते हैं. S is 1, 3, 4 and 6. Input set S and output set S 1, 3, 4 and 6. And relation is defined in such a manner that A should be less than B. A should be the first element of ordered pair that should be less than second element of the ordered pair. So if we take A is equal to 1, then 1 will be less than 3, 4 and 6. So 1 is related with 3, 1 is related with 4 and 1 is related with 6. So R will be having elements 1, 3, 1, 4, 1, 6. Similarly, 2 is less than 4, so 2 तो है ही नहीं, 2 क्यों लिख रहे हैं? 3 is the second element of set S. ठीक है, तो 3 is less than 4 and 6. So other elements will be 3, 4 and 3, 6. And lastly, 4 is less than 6 only. So 4, 6 is last ordered pair of relation R. Okay. Last ordered pair of relation R. Isn't it so? Total 6 ordered pairs are there in relation R. अब यहीं पे अगर हम R इनवर्स डिफाइन करें, R इनवर्स डोमेन और रेंज तो समझ ही गए, उसको दोबारा से मेंशन करने की जरूरत नहीं है. लेट अस से इफ वी डिफाइन R inverse. So R inverse will basically having ordered pairs B comma A such that A comma B is element of R. So we can write that R inverse will be equal to 3 comma 1, 1 comma 3, 1 comma 4 था, तो 3 comma 1, 4 comma 1, 6 comma 1, 4 comma 3, 6 comma 3 and 6 comma 4. This will be our R inverse. Isn't it so? क्या ये क्लियर है? सेम 6 एलिमेंट्स, बस ऑर्डर चेंज हो जाएगा. या अगर डिफाइन ही करते आर इनवर्स को तो ऐसे भी लिख सकते थे कि आर इनवर्स इज इक्वल टू बी कॉमा ए सच दैट रिलेशनशिप क्या था हमारा, ए इज लेस देन बी, सच दैट ए इज लेस देन बी. ये भी लिख सकते थे सच दैट ए इज लेस देन बी और बी इज ग्रेटर देन ए, विच एवर वे यू सूट इट. तो बी इज ग्रेटर देन ए और ए इज लेस देन बी, कैसे भी लिखो. एंड बोथ ए एंड बी आर एलिमेंट ऑफ सेट एस. और फ्रेश वे में 1, 3, 4, 6 सेट एस लिखते दोनों तरफ और अपने एंड पे तुम एक्सरसाइज की तरह कर लेना और फिर देखना कि सारे के सारे एलिमेंट्स ये आने वाले हैं. इनवर्स की डेफिनेशन प्रॉपर्ली लिख दो और फिर रिलेशन को डिफाइन करके और रिलेशन के सारे ऑर्डर्ड पेयर्स मेंशन कर दो. बात एक ही है. ठीक है, तो चाहे आर से आर इनवर्स पे पहुंच जाओ या आर की डेफिनेशन से आर इनवर्स की डेफिनेशन निकाल लो और फिर वहां से अपने एलिमेंट्स निकाल लो. बोथ आर वन एंड द सेम थिंग्स. तो दैट इज हाउ वी डिफाइन अ रिलेशन, इनवर्स ऑफ अ रिलेशन. इज दैट क्लियर? ठीक है, इज दैट मच क्लियर? ओके. सो आज के सेशन में इतना ही रखते हैं. विल ऑल्सो बी डूइंग सम एग्जाम्पल्स ऑफ रिलेशन, टॉपिक रिलेशन, बट वो नेक्स्ट सेशन में करेंगे. इस सेशन में इतना ही रखते हैं. आई बिलीव जो भी हमने डिस्कस किया वो सबको समझ में आया होगा. एंड इफ देयर इज एनी डाउट व्हाट्सो एवर in any concept, then make sure to comment about that doubt. और अगर सेशन पसंद आया then make sure to give your feedback in the comments as well, and hit the like for this session. And if you've not already subscribed to the channel, then make sure to subscribe to the channel as well as press the bell icon. That's all for this session. Bye bye, take care. On next session we'll be doing some examples, some practice questions on relations. That's all. Bye bye, keep learning.